QuickSort is a sorting algorithm that uses two key concepts, a pivot and divide and conquer. Let's say we have an array and we want to sort it. QuickSort starts by choosing a pivot element and then partitions the array into subarrays. The elements smaller than the pivot to the left array and the elements bigger than the pivot to the right array. Then we apply the same principles for those two subarrays, and we continue doing this until we reach subarrays of only one element. At this point, everything is sorted. For this video, I'll use Java to implement QuickSort, but you can choose any programming language. As you can see, I've already set up a basic template with helper methods to swap elements and print the arrays. So let's start with our array. As we've discussed, the first step is to choose a pivot. For simplicity, we'll use the last element as our pivot, but we'll explore other strategies later. Now that we have our pivot, we'll look through the array, comparing each element to the pivot and putting each lower element at the beginning of the array. Finally, we put our pivot in the right place and return the index of the pivot. Now we apply this to our current array and repeat it recursively for the resulting subarrays. And that's it. Let's run the code and watch the array sort itself. If you're finding this video helpful so far, don't forget to like and subscribe for more programming tutorials. Now, let's talk complexity. The average time complexity for QuickSort is n log n, but the worst case scenario is n squared. This happens if the pivot is consistently the biggest or the smallest element in the array, which is why pivot choice is a key factor in QuickSort. Those are three popular strategies for picking pivots. Picking the first or the last element. It's simple but risky. If the array is already sorted, we end up with the worst case. Picking the middle element. It's a balanced approach that tends to split the array evenly. Lastly, picking a random pivot. For this strategy, we have no pattern where the worst case scenario happens. QuickSort is efficient on large datasets, but not a good choice for small datasets. That's why a hybrid approach often works best. We can use QuickSort for larger chunks and switch to Insertion Sort as the subarrays get smaller. Another particular way we can implement QuickSort is with a dual pivot. It is faster, but the worst case scenario is still n squared. Let us know in the comments, what's your preferred way to implement QuickSort? And if you're ready for more algorithms, check out our next video.